Get the butterfly.
In one short month, the mind of the baby human has been able not only to find an object, but to actually retrieve it.
You found it.
I have something else to play with. We'll give you this.
To further pursue the question, Dr. Andrew Meltzoff followed how the concept of hidden evolves in the mind of a child.
So here's what I'm going to do with these. See this pig? Pig. Yeah, you can play with it.
What happens if not only the object is hidden, but the action is also concealed?
Different. I'll do something different. Watch this.
First, Dr. Meltzoff hides a toy under his hand in front of 18-month-old Emma's eyes.
There's the pig.
She has no difficulty finding the toy.
Thank you. Now watch this, Emma. I hide the pig.
Then he does something different.
And I move the pig here. Watch this carefully. Where's the pig?
It's the old shell game.
No pig. Where's the pig? Yeah, it's supposed to be around, isn't it? Okay. Where's the pig? This is about object permanence. Where is that pig?
Emma can't figure it out at all.
It's not there.
Even though there is clearly a bump under the towel, she has no idea what happened to the toy because both the object and the action were hidden.
It's hard to figure out, isn't it?
It will take her a few more months before she successfully plays this game of hide and seek.
Watch.
While the baby human is discovering that objects exist even when they're out of sight, they also learn about the properties of those objects, how they behave, their size, their shape. But researchers wanted to know just how early the baby human makes these discoveries. A large green ball is held above a narrow cylinder. 5-month-old Lauren stares at it in rapt attention. When the wall is removed, presto magic. The ball is inside the cylinder. Lauren stares at it, trying to understand how this could at all be possible. Even as young as 5 months, she knows when the laws of the universe have been violated. Then the container is changed into a wider one. Lauren isn't interested. Like any normal adult, she finds it boring. Only the unexpected is entertaining. But the baby human can't learn about the physical world all at once. It's a step-by-step process, and width is different from height. 7.5-month-old Madison is shown a tall object go in and out of a container. It's obviously not a very interesting event to watch. But then the same object is lowered into a short container. Madison can't believe her eyes. At 7.5 months, she knows this is impossible. So there is a progression in understanding the properties of objects. Psychologists found that as the baby human learns about the physical world, they form categories like under, behind, and inside. And what's surprising is that they learn each category one at a time. But because we now know how baby humans learn about physical laws one by one, researchers decided to test what happens when they're faced with more than one law at a time. At Rachel Keene's lab, they put baby humans to the test.
Is that fun? Ready? We'll do it.
When a ball rolls down a track, 9-month-old Julie needs little coaxing to catch it.
Good job. Good job, Julie. Got it.
Once the researcher establishes that Julie is interested in the ball,
Ready for the screen?
she begins the testing. A screen is placed partway down the ramp. Julie has no trouble tracking the ball despite the obstacle. This shows that she understands a key concept of object permanence and expects the ball to reappear on the other side of the screen.
You get good checking there.
Then Kaylee is brought in for the next test. She is also 9 months. She too tracks the ball when it goes behind the screen.
I give it back every time I come.
Then a green wall is placed on the track. Kaylee knows which side of the wall to expect the ball because she knows another important principle of physics, that a solid object can't pass through another solid object.
Can I have this? You ready?
Now comes the hardest part of the experiment. Both the wall and the screen are put on the track in front of her eyes.
Where did it go?
Kaylee is perplexed.
Where'd the ball go?
She sees the green wall sticking up behind the screen, but still expects the ball to appear on her right side.
Where's the ball, Kaylee?
She uses what she's learned about the screen to guide her and forgets about the green barrier. At 9 months, she's not yet able to put the two laws together. But it doesn't mean the baby human can't put 1 and 1 together. Once baby humans have learned that objects exist, the next thing they try to understand is how to organize and sort those objects. The sense of numbers is one of the ways they do that. Psychologists believe that the baby human is born with an innate capacity for understanding numbers. Sydney may not be able to count yet, but she knows she has 1 mummy and 1 daddy. Some researchers believe that the first encounter with adding and subtracting may be from the caregivers around the baby human.
Some more.
But when one parent goes away, Sydney knows something is missing. And when the other leaves, there are none. And Sydney also knows that 2 is more than 1. Just how early does this amazing capacity in mathematics begin? That's what psychologist Karen Wynn was curious to find out. The first experiment involves addition. 6-month Abigail is placed in front of a stage.
All right. Well, first I want to introduce you to a couple things about our stage. It has a solid body.
Like at a magic show, she's introduced to the actors and set.
And watch the screen.
She is shown 1 toy. Then 2 toys. Then Abigail's addition skills are tested. She is shown the equation of 1 toy plus another toy. When the screen comes down, there are 2 toys. But what happens when she's shown something impossible? 1 toy disappears behind a screen and is joined by a second one.
And watch the screen.
But when the screen comes down, there's only 1 toy. Something doesn't add up. Abigail stares in disbelief as if she knows that this isn't the correct answer.
And up goes the screen.
As the scenes alternate between possible and impossible, Abigail responds accordingly, staring longer at the impossible and quickly getting bored with the correct answer.
Look.
Next comes subtraction. For this, another 6-month-old, Connor, is brought in to test his skills. He's shown 2 toys.
And look.
1 toy is taken away. He's left to make his own calculations. But when the screen comes down, there are still 2 toys. Connor looks perplexed. It's definitely not what he expected.
All right, you're going to get set for the next one back here.
Next, there's a change. 2 toys,
And up goes the screen. And look.
take away 1.
Where's he going?
This time, there's only 1 toy left. Connor quickly loses interest because there's nothing engaging in something so obvious. Like in Abigail's experiment with addition, Connor's attention is only attracted when the subtraction doesn't compute. This suggests to the researchers that even at 6 months of age, babies may have a rudimentary sense of numbers. But besides adding and subtracting, the human sense of numbers involves a large element of perception. It's what allows humans to grasp the idea of more and less. The baby human, like the adult of the species, does that by comparing and contrasting. Researchers have learned that Waverly can't tell which of the 3 piles in front of her has the most donuts. Only when the difference is large enough can she tell visually that the one on the left is smaller than the one in the middle. But she still can't tell the difference between the one in the middle and the one on the right. So when does the baby human move beyond perception and actually begin to think in numbers? Is it once they are able to count? At 2.5 years of age, Mackenzie can recite the numbers from 1 to 10.
1, 2, 3, 4, 5. Okay, please now.
Her father, like every proud parent, thinks his child can count.
8, 9.
But what does she understand about those numerals? Does she understand that the words she is saying actually signify an amount of things?
1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
What's after 5?
A table.
But her fingers point randomly to the crackers, assigning them arbitrary numbers.
But don't touch them.
Okay, how about now?
1, 2, 3, 4.
Even so, somewhere in the back of her mind, she knows that counting and numbers have something to do with lining things up and sorting.
Is that 9? What number is this? If that's 9, what number is this? Say 10?
A hand in the middle.
Okay. Can you give Ben a 3 goldfish?
And what happens when her father asks her for 3 crackers?
Don't move. Don't dump it out.
2.
Eat them.
Wait.
She simply repeats her mechanical counting and has no idea how many she's given her father.
I don't eat them.
Well, like all the close stuff we can do.
Don't eat them. I don't knock them to. Don't eat them. It's counting time.
It'll be a few years yet before she really understands what counting is.
Put that one. Can you put one on there?
Numbers and counting are one way humans organize their thoughts about the world around them.
Oh, nice. It's a house, a tall tower.
Sorting and forming categories are another.
This one?
Baby humans begin this process of thinking far earlier than most people would imagine. It's a complicated mental activity that shows they can perceive deeper patterns in their surroundings.
Yes, you did great.
Things can be sorted by shape, color, and size.
Good job.
It may look like child's play, but it is fundamental to understanding far more sophisticated concepts.
You do it.
It's the foundation of logical reasoning. Having learned to sort, Caitlin knows that only the animals belong inside the barn when day is done. Because now she's beginning to understand that the world has an underlying sense of order. The next step will be discovering how to control it. After the baby human has learned that the world is full of objects that come in all shapes and sizes,